Hey class 12, let's continue our class. Well, as of now we have done the color code of carbon register, isn't it? So now today we'll start the next topic on page number 103 in your book. So there is a topic like this: temperature dependence of resistivity. So today we'll discuss what happens if you increase the temperature of a conductor or insulator or semiconductor, then what happens to the resistivity of that particular material. Okay, so so in previous class we have discussed that conductivity equals to how much? You know this formula, isn't it? Conductivity equals to how much? Or sigma equals to how much? N E squared tau by mass, isn't it? If this is your conductivity, then resistivity equals to how much? Reciprocal of conductivity, isn't it? Ulta हुन्छ नि त, m by n e square tau. So now see, if you increase the temperature of particular material, mass will not increase, isn't it? Yes. So this, just take it out. Next, for if you take conductor, then this will not increase, isn't it? Number of electron, and charge also does not increase. So it depends on this, isn't it? Relaxation time. This tau is your relaxation time, isn't it? So write down this one. Now write down for conductor. Okay, for conductor, for insulator and semiconductor we have to do, isn't it? So write down for conductor, for conductor. Let's see what happens. See, this is your conductor, isn't it? This is our conductor. So there is a electron, isn't it? So whenever you increase the temperature, its velocity increases, isn't it? Yes or no? This is the time between the two collision, is your relaxation time, isn't it? If you increase the temperature, velocity increases, isn't it? So if velocity increase, then relaxation time decreases, isn't it? Yes or no? छिटो ठोकिन्छ कि ठोकिँदैन योसँग? यो स्पिडमा गयो भने छिटो ठोकिन्छ कि ठोकिँदैन? So now write down in word, you have to write. So if you increase temperature, what happens? Tau decrease. So what happens? See, so now rho equals to how much? 1 by tau, isn't it? Tau. So if this decrease, then this increase. So rho increase if tau decrease, isn't it? So hope you understood this. So in your copy, write down the in word. Okay, this one. So write down, if temperature increase, if temperature increases for conductor. Okay, this one is for conductor. If temperature increases, the thermal velocity slash random velocity, you can say random velocity increase of the free electron. Okay, free electron increases. So if you increase the temperature, then the random velocity or the thermal velocity increase of a electron, isn't it? So which result in more frequent collision, isn't it? So more frequent collision, isn't it? Chito chito ke huncha, they will collide each other. thus what happens, thus the relaxation time that is your tau, isn't it, decrease, isn't it? So next write down since, next line write down, since rho equals to how much, 1 by tau, isn't it? Yes or no? Or you can write rho equal inversely proportional with the tau. So if this decreased, so this increased. So write down, therefore resistivity increase with temperature. So this is for first case, that is your conductor, right? So copy. Now next we have so this you know this one, R equals to how much, rho L by E. So temperature increase, resistivity increase, resistance increase, isn't it? So if you cool down and if you take this as 0, घटायो भने टेम्परेचर घटायो भने के हुन्छ, रेजिस्टिभिटी घट्छ, रेजिस्टिभिटी घट्यो भने के हुन्छ, रेजिस्टेन्स घट्छ. ओके, सो दिस टाइप अफ कंडक्टर इज अल्सो कॉल्ड सुपर कंडक्टर. ओके, सुपर कंडक्टर. So next write down for semiconductor, isn't it? For semiconductor. Next write down for semiconductor. What happens? Let's see. This is for conductor, isn't it? So direct write down for a semiconductor and insulator. Okay. For second case, for semiconductor or insulator, what happens? Okay, see, you know that semiconductor, isn't it? You are doing in chemistry also, isn't it? It makes of covalent bond, isn't it? Whenever you increase the temperature, it breaks into or split into an ions and it conduct the electricity. Clear? So you'll see that one, this creates, whenever you increase the temperature in semiconductor, what happens? Electron and hole forms, isn't it? You know, in solid, isn't it? Chemistry. So they conduct. So now write down resistivity equals to how much? M by N E square tau, isn't it? So whenever you increase temperature, number of electron, this increases, isn't it? So N increases. Clear? So what happens? So don't go with this one, tau relaxation time, just N increases, it can omit this tau, isn't it? It can dominate this tau. So N increases, then rho decreases, isn't it? Why? Because this is your inversely proportional, isn't it? Number of electron if increase, then resistivity decrease. So you'll get whenever you increase temperature in a semiconductor, then resistivity decrease. Clear? Resistivity decreases. So if you plot the graph, then this is your temperature, this is your, sorry, this write down resistivity, this is your temperature. If you increase the temperature in conductor, resistivity increase, but in insulator and what you call semiconductor, if you increase temperature, then resistivity decrease. So this type of graph is there. So on page number 104, there is your graph, draw it. Okay, first one is for conductor and last one is your semiconductor. draw it and show it to me. So next we have electrical energy and power. You know this one, isn't it? Electrical energy and power. So now we have cell combination. Okay, so write down cell. This is very important to understand this one. Sorry, this further topics. So you have to understand the cell. What is cell? What is EMF? What is potential? Okay. So now write down cell. Cell, you know, isn't it? Cell, cell, isn't it? You have a smartphone. There also you have cell, isn't it? And you have TV monitor, remote are there. There is also a cell. Those are also a cell. So cell is nothing but a, what is that? Cell is combination of, so cell is first unit is your cell in battery, isn't it? If you combine this, you'll get battery, isn't it? Cell plus cell, battery. Clear? So in biology, cell plus cell, organ or tissue you'll get, isn't it? So anyway, cell you understood, isn't it? Like your battery, pencil battery, that is your cell, isn't it? And if you go and buy your battery, you'll get remote 1.5 volt, isn't it? Clear? So but if you take it to your lab and if you want to measure this, potential, you'll get voltmeter, isn't it? Voltmeter लगाएर के गर्छ तिमीले, यसको पोटेन्शियल गर्छ. उसमा लेखेको हुन्छ 1.5 volt or 2 volt. Okay, let's see, 2 volt is, but your reading will not give the actual 2 volt. Okay, your reading तिमीले 2 volt पाउँदैन. Why? So you have new term, electromotive force and potential. Potential is your 2 volt, isn't it? So now what happens whenever you connect with your voltmeter, you will not get the 2 volt, isn't it? त तिमीले भन्छ झुकाएर दोकानेले हैन, तर हैन, यसले के हुन्छ 2 volt रिटर्न हुन्छ. Okay, what happens? Let's see. To understand this, just write down, whenever in a circuit there is resistance, then there is potential drop. You line here. Whenever in any circuit there is resistance, then there is potential drop. You line here. So we know V equals to IR, isn't it? IR. So this is your cell actually, isn't it? There is a rod, cathode and anode, you know, isn't it, in chemistry, right? And you are join this with resistance, isn't it? And you are connecting with voltmeter. Clear? So there is chemical, isn't it, inside a cell. So this chemical also resists the flow of current. Okay, whenever there is, and that resistance is called internal resistance. Internal resistance. And this resistance is your external resistance. So this can be written as R and this can be written as R. Okay, so you'll get 1.9 volt, okay, in your reading. Okay, let's see, let's suppose. Okay, so what happens, see, whenever you connect this, as this is your resistance R, and this is how you have to draw your circuit. Now battery, then you have internal resistance, then this is how current flows. Okay, this is your external resistance, this is your inside a cell, this is your inside a cell, isn't it? Resistance. So this all together is called EMF, or you can write epsilon. Okay, clear? So now let's start with EMF. Okay, this is your EMF. So E equals to how much? Let's see. Let me draw here. Let me calculate here. So E equals to how much? External IR, clear, then plus internal potential drop, isn't it? External potential drop, internal potential drop, clear? So EMF how much? So this is how much? E equals to, this is V, isn't it? Plus IR, clear? So I equals to how much? I equals to E by, you can write this one, use this one, okay, R plus R, clear? So this is your EMF 6, isn't it? Okay, good, diagram here 6, sorry 2, isn't it? 2 equals to, you got it here, 1.9 plus internal resistance 0.1, so you'll get 2 equals to 2. Understood? So this is what you have to understand: internal resistance and external resistance. Very, very important, this stuff. So this is your volt. External potential drop, internal potential drop also, I, current I into R, isn't it? So when you'll get maximum current through this circuit, so write down I max equals to, so this should be, external resistance should be 0, so E by R. So this is the I max. Okay, now they may ask, sometime they may ask the factor affecting the internal resistance. Okay, so write down factor affecting the internal resistance. So factor affecting the internal resistance, so 3 factors are there, so write down factors affecting the internal resistance. This resistance, what are the factor? Okay, so first write down distance between the electrodes, distance between the electrodes. This means if the distance is near, then you'll get more current. Distance away, then less, isn't it? Resistance, isn't it? So second, you have area of electrode, area of this electrode. Okay, ठुलो एरिया छ भने ठुलो चार्ज भेट्छ, area of electrode. Third one, nature of electrolytes, NATUR, nature of electrolytes. You have done in chemistry also. Okay, just revision this one, clear? So internal resistance, external resistance, potential drop. So this is your EMF. Okay, whatever your potential is, not the EMF. Okay, EMF मा चाहिँ के हुन्छ, external drop into internal, sorry, addition of external drop and internal drop potential. Okay, so whenever there is a resistance in a circuit, then there is a potential drop. Remember this word, clear? Sorry, this sentence, whenever there is a resistance in a circuit, then there is a potential drop. So thank you for today. So make notes, and tomorrow or day after tomorrow you have to post. Okay, so well, thank you.